The board has n+1 squares. The hash starts at 0, goes to n. Uses a roulette from n with equal probability. The hash spins the wheel and moves exactly the number indicated. If this would send him beyond, he turns around the square and goes back by the excessive number of squares. Okay, so distance, okay. When the hash arrives at the square, he wins and ends the game. Find the probability may spin most k times. So, okay, so for each n, I can get the roulette, and then that's like probability. And then again, probability, again, until I come to, okay, can we do something with matrix exponentiation? No, the matrices are too huge. Push DP, let's see, push DP. Okay, what's the probability here? And then 1/10 is here, 1/10 is here, 1/10 is here, and then if I go here, then 1/10 probability. That's easy, huh? Just DP and K. That's easy. It's just that I need to have like mod int int to type def this, and now I need to say okay int and mk, right? Yeah. Okay, oops. Okay. For each of the k times, probability of getting to n+1 c plus 1, probability having here is 0. For each of the k times, I can move the wheel with dp off, so like the new dp. Actually, new dp is again this, so the new dp of I plus j, if I plus j is smaller than n, new dp of I plus j is 10th to what I have here, so it's dp of I divided by m. Else if I plus j equals Yeah, that's correct as well. At most k times or what? Okay, if else new dp of I how is gonna be this n minus, so I plus j minus n is what it remains, n minus this is dp of I m a. And now I need, if it is m, I stop there. Yeah, for each iteration, for each k repetitions, you need to go through each of these, not including n, and I need to do this. Then I need dp swap new dp. Yes, but what I need else to do is I need to remember what's the probability. The probability would be the new dp at position n, right? And now I need to just see how the answer. What happens here? One here, one, and now we go over all of these. So one, go over all of these. You add to the new dp if this is the case. Maybe +1 or something? No. New dp bit n. Okay, what happens here at n? So I want to see how the new dp works. So you either from 1 to m. Okay, that was stupid. That's correct. That is correct. I think that's correct. That's accepted. Sugoroku is like you're given some line, and there are some squares from 0 to 1 to n, and you are using this roulette wheel with equal probability, and what comes up on the roulette wheel, you move that many places to the right. So there are at most m places to the right you can move. But if the roulette wheel comes more than n, you actually go to n and then you go back what is remaining. And this problem can actually be solved even if m is like big, is very big, but like even like m if it is 1000 can be solved, because the dp here is only, so it's only a simple dp. You go through all of the k numbers, through all of the k like times you're gonna throw the roulette wheel, right? That's the maximum number of times, and you have this whole dp, and then just for each n you go through each m. So for each number, for each position, you go through each of these n and just like divide the probability equally. And if this is not true, then you go backwards actually. So, and when you go, the answer is the new dp at the end position. So like the answer just gets probability more and more. And now you start with probability 1 to be on the 0 position, but after one throw, this probability is gonna develop through the k positions, through the next m positions. And then the next throw, this probability is gonna still develop like that. And then when it comes behind, it's like this has to be done. But even if m is very huge, like let's say 1000, what you can do is you can have like lazy sex tree, and you can just when you develop this probability, instead of doing for loop, you can just do lazy sex tree update, add this probability to every node in this range, and then you query out this node with log n, and so like it's really, this loop can be done in log n time. So that's E.